In this video presentation endorsed by the iAPSCC, International Association of Planners, Schedulers, and Cost Controllers, we'll learn about physical asset management in heavy industry to achieve high process availability and high physical production asset reliability and utilization at the lowest risk cost, increasing revenue and profits for an organization, and recognizing the value contribution of maintenance and project planning, scheduling, and controls. Before we begin, it's worth noting that physical asset management refers to the maintenance, operation, and construction of physical production assets and supporting infrastructure. We classify the requirement for effective operating and maintenance as asset integrity, the alloys that make up the physical assets, and process integrity, the conversion of molecules within the alloys through pressure, temperature, flow, and mechanical/chemical conversions. Basically, manufacturing raw materials into finished marketable products. Lastly, we have mechanical integrity, which we generally refer to as rotating, electrical, instrumentation, and infrastructure, typically associated with routine maintenance. Now, let's look at the 4 elements and 6 processes within the Reliability Asset Management Program, referred to as the RAMP model. The first element of RAMP is physical asset management, where we highlight the asset owners, known as the Asset Management Team, or AMT. The AMT are also known as the gatekeepers, which we'll discuss in a moment. The first, and most often referred to as the asset owner, is operations. Operations are primarily focused on process integrity. For example, cleaning, catalyst replacement, filters, analyzers, and so on, which we refer to as requiring a shutdown. Operations provides marked up P and IDs, lockout tagout isolations, permitting, and other key data and information. Technical is another asset owner where the inspection team will focus on asset integrity, which requires a turnaround, and the reliability department will focus on mechanical integrity, primarily rotating and electrical/instrumentation scope and budget, which often requires an asset or system outage. Technical provide planning with inspection and test plans, IDPs, along with other key data and information. Lastly, we have the engineering asset owner, made up of process/chemical engineering and mechanical engineering, supporting operations, and technical with engineering support, such as engineering work requests or management of change, MOC. The second element of RAMP is asset management strategies. This is where the AMT determines various strategies necessary for optimizing asset reliability and process availability aimed at risk mitigation and business performance optimization. This is where planning services receive significant data and information required to plan effectively. The third element of RAMP contains work management and resource management. Within work management, we have centralized planning as a service to AMT. When work notifications/requests are presented to the AMT gatekeepers, they must pragmatically justify the approval to spend or invest money. This is done using a formal risk-cost-benefit analysis tool and methodology. Or, in the case of a scheduled STO event, a risk-based scope review process might be used. Often, to justify an expense, the AMT might request a high-level estimate, HLE, from central planning. If the AMT approves the expenditure with an authorization for expenditure or AFE, central planning will assign the work notification/request to the appropriate functional planning resource, who will then create a work order and begin the planning process for the various work types, for example, shutdown, major maintenance, routine, projects, etc., based on discipline, i.e., rotating/mechanical, electrical/instrumentation, and stationary. The next process falls under resource management with ready-to-schedule work for execution. This is where scheduling functional resources within central planning adds significant value to maintenance and project resource efficiency, tool time, and cost savings. A key component of RAMP is the technology and digitalization of its elements and processes, known by many names, such as Computerized Maintenance Management System, CMMS, or Data Lake, Enterprise Resource Management Program, ERP, and so on. This is where data and documents are stored and historical information is available for planners. The final element of RAMP is performance management. This is where data and information are used to continually improve physical asset performance, planning accuracy, and budget versus cost. This data, known also as lessons learned, can then be used by the AMT to improve asset management strategies, shutdown, turnaround, outage predictability, and competitiveness, and by central planning to improve planning, scheduling, and controls. To summarize, the RAMP model is an important illustration of how various stakeholders and functional teams work together for a common vision, each with their own mission. The services provided by central planning, scheduling, and controls are based on a measurable mission, which we'll discuss in more detail in future lessons. If you're not already a member of the International Association of Planners, Schedulers, and Cost Controllers, be sure to join www.iAPSCC.com as a sustaining member to earn your digital credential badge and start earning the recognition and rewards you deserve.